The Monaco Grand Prix, it's just a little bit special, isn't it? It's Formula One's shortest race in terms of the distance covered, but not the amount of time it takes the drivers to complete the race distance on the twisty, turny streets of the Mediterranean Principality. The nature of the Monte Carlo circuit means that the cars need a very specific setup, and it's a real challenge for the drivers as well. And you hear all the time from the drivers about they feel that if their rivals are close, doesn't matter because the walls are even closer. Monaco is just really, really difficult. But it's not just difficult for those drivers, as I said, it's also difficult for the engineers. And going into the Monaco Grand Prix, the cars need a very specific package of parts. The track itself is a challenge, but one of the most obvious factors you see in Monaco, and we've talked about it for many years, are the big wings you see on the car. Here's McLaren's high downforce wing package. And on the topic of McLaren and what you need to fit to the car to get around this circuit and try to win the Monaco Grand Prix, let's hear from a man whose cars look likely to be in a real challenging position to do just that. It's Andrea Stella from McLaren talking to Lawrence Barretto.
So Andrea, just tell us the new bits that are on the car for this weekend.
Yeah, some new bits. Like I read this morning the submission from all teams, and pretty much is a copy and paste for all teams, because you come to Monaco, is a one-off circuit, very specific. It's one of those circuits called, we use a technicality here, low isochronal. It means that you want to add as much downforce, and even if this downforce comes with some drag, that's not a problem, because here 1 point of downforce is much more valuable than 1 point of drag. Okay, so we're gonna have a bigger rear wing, and with the bigger rear wing, the upper one, it also comes a bigger lower wing. These elements, they come with, like I said before, a lot of downforce. Like the car will have quite a bit more than what we had in Imola, where in Imola the straight line speed is important. Here is not very important, but as you can imagine, just intuitively, these elements also give quite a lot more downforce, and also these elements work in conjunction with the diffuser, so they help extract the flow from underneath the car, so they work in an integrated way with the floor, and overall the car becomes much more powerful in terms of generating aerodynamic grip, which is what you need here in Monaco.
Oh, that's absolutely fascinating. A real insight into the components that you need to get around Monaco, particularly in aerodynamic terms. So as you can see here is the big old wing that McLaren have fitted to their car. But they're not alone in the big wing club. Everybody's got big wings on their car. Let's check out Red Bull, for example. Max Verstappen really thinks he's got a chance to beat the McLarens around this circuit, but doesn't he always? This is actually Yuki Tsunoda's car, and it's worth noting that once again Red Bull are splitting their aerodynamic strategy between the two cars. Yuki Tsunoda here with the long nose that comes down to that front element of the front wing. Max Verstappen sticking with the short nose. We saw the same split with Liam Lawson when he was in the team before Yuki Tsunoda replaced him. But the wing itself here is worth taking a look at as well. As you can see here, it's got an absolutely enormous gurney on the upper element, and that gurney is so big that I just think you might have to check if it's got any of Dan's DNA in it, because it's so much of a gurney. If you're in America, you haven't got a clue what I'm talking about. It's the gurney flap, or you probably call it a wicker bill. I think wicker bill sounds great, but it's a gurney flap. So let's take a look at the rear end of the Red Bull as well, because the rear wing on that car is pretty impressive. I mean, look here, it's almost vertical in the center section. That's how much, you've got to think the air is hitting this at the best part of 300 kph as the cars come through the tunnel. So the aerodynamic drag off that wing is going to be absolutely enormous. But because of the low average speed around Monaco, that aerodynamic drag penalty, that wind resistance, is going to be much lower than it would be at other circuits. And therefore, the efficiency, how much downforce you get for the amount of drag that it produces, it doesn't really matter. The aerodynamic efficiency can be really quite low for the wings on these cars. All that really matters is the downforce, and that's why we like to call it dirty downforce on these cars, because its downforce is more efficient, more important than the aerodynamic efficiency of the overall car, and that is really critical. I actually think the wing is vertical in this centre section. It's almost like a Hanford device for those who remember the old oval racing days back at tracks like Michigan Superspeedway, and that's taking you right back, and I'm showing my age there. Another team I wanted to show you in the pit lane that is quite interesting is Ferrari. This is the Ferrari rear wing on the car this weekend in Monaco, and you may think it looks a little bit familiar. Ignore the paint job because Ferrari have changed sponsors. Well, they haven't changed them, they've just changed the amount of bodywork that's covered by the sponsor logos. Here's the wing they ran in 2024. Do you want to play Spot the Difference? You lose. Ferrari are actually running their 2024 rear wing package for a couple of reasons. Firstly, the teams can save a huge amount of money in this cost cap era by running an old specification wing. Don't have to manufacture any new parts. You've already done a lot of the development work. It saves a huge amount of time and energy. And every single team in Formula One actually develops their Monaco package really early on. As in the early stages of the aerodynamic development of the car, the Monaco package is actually one of the first things they'll look at. So they already had these parts in development probably around the time of the Monaco Grand Prix last year. With stable regulations, Ferrari took a look at the back of this car and just went, let's fit the old parts. And they're not alone in it. One team that has fitted an awful lot of old parts to its car, including the entire car, is Williams, who are running last year's car this year with some modifications, and it's kind of working out well for them. Here's the rear wing on Williams for this weekend, and one of our team here, looking at a slightly different angle, this angle here, was saying when they look at that, it's like, it's big enough to have a picnic off that rear wing, and you can see his point. It's absolutely enormous, that lower element. And then the top element, it's still pretty steep, not quite as steep as the Red Bull wing, but it's pretty steep. And again, that wing may look a bit familiar because this is the wing from last year's Williams, just with a different sticker on the top. It said Williams at the top of it last year. And actually that's what Williams has done. It's quite interesting. They've taken that to a real extreme. They're essentially running a different package of parts to what they ran last year, or at least the same parts in a different order. It's a bit like having the same recipe and coming up with a different result, but it works out well for the Williams team. One area I'd like to draw everybody's attention to is at the rear of the car. It's the beam wing on the Williams, and there are some new things we haven't seen before. Well, we have seen before, but we haven't looked at in detail. I just want to stop here. Look at how steep and how large this beam wing is on the Williams. At first I thought it was a single element wing, but as you come up, you can actually start to see the second element coming into play. So really quite steep, really quite draggy again, but effective in terms of generating downforce. And then you can see as we come around to looking at the whole rear end of the car, Williams has gone back into the parts bin and found this little centerline winglet that we've seen earlier in the season as well. That's a new for 2025 part, but the rest of it is pretty similar to what the team ran in 2024, albeit with a few tweaks here and there. This is a 2024 package racing in 2025, and so far it looks pretty good, doesn't it? So technical development on a Formula One car might not be everything when it comes to winning at Monaco, but the teams do still have to work really extensively. And to hear a little bit more about this package on the Williams, Paul Williams was talking to Lawrence Barretto in the pit lane.
The circuit itself has a very low break-even efficiency, so that is the ratio that you can trade downforce and drag. So actually it's a very low drag sensitive circuit rather than a high downforce sensitivity, so it's around 1 in the race. So you see teams bring large rear wings, so on our car we've got the largest rear wing that we own, and with that as you push the upper cluster it becomes more stressed and you need more support, so that's why you see lower beam wings which themselves bring local load but also support the upper cluster as they tend to be a little bit more unstable as you push those elements.
Paul Williams there, the chief race engineer at Williams. Let's though have a little bit of a think about that low average speed and the implications of that, because when you're driving very slowly on a very twisty circuit on what could be quite a hot spring day in Monte Carlo, you're going to have a lot less air going through the car than you would at, say, Monza. There has been a little bit of a trend up and down the pit lane in Monaco this year, and it's all to do with the front brake cooling package. And it's not just the cooling scoops. In fact, a few teams have tweaked their cooling scoops to the largest version they've got for the brake demands, but a lot of teams have actually changed their cooling outlets. And before we take a close look at that section of the car, because there are some interesting details, Lawrence Barretto was exploring that exact issue with the Williams team earlier on.
This track is the highest brake energy density, which is a fancy way of saying that the brakes get a pretty hard time here without much respite, which is due to the lack of straights. So to cope with that, we open up the brake cooling, which allows the brake material to operate in its correct window. So you see plenty of teams opening up their front brake ducts.
Well, I thought it's worth just taking a look at to see what we were just talking about there. Here is the cooling outlet on the front of the Williams, and it's been enlarged, as most teams have tried here. And you can see here, it's an interesting shape, and the shapes around this area are what engineers absolutely love to play with, because there's quite a lot of freedom with what you can do in terms of this ducting, because it's not just what you see on the outside. What's on the inside matters as well, and that's actually really important around here, because there's a huge amount of air flowing through there. You've got to keep the brakes cool, but there's also a big aerodynamic effect on the cars. It's also worth taking a look at this cutout on the upper suspension. That's to allow the front wheels to turn without clipping, and we're going to come back to that specific suspension part in a few moments. I think it's worth taking a look at the front brake cooling outlets on the Red Bull in particular. They're not the only team with new ones, but the Red Bull ones I've found are particularly interesting, and I'll explain why. If you have a look here, the outlets here have been enlarged quite significantly, and because of the way the internals have been designed, you've got this yellow section on the inside, and it really just highlights the changes. Now we can get a slightly better angle of that brake cooling outlet if we look across the car. Here we can see you've got a couple of cooling channels and a lovely little detail at the top there. I'll highlight in a moment. And you've got a separate segment down here at the bottom. You've got this section on the inside, and what you're seeing there are different sections of the brake cooling package. Some of the air flows through there are going to be cooling the caliper, some of them are going to be going to the disc, and some of them might be going straight through for aerodynamic reasons rather than pure brake cooling. We've heard a lot about that this season already, haven't we? But I want to highlight this duct layout and compare it to the duct layout that Red Bull ran last year at Monaco. Now, look how much smaller this package is. It's a much smaller cooling outlet for the same circuit, with the same rule set, and a car that follows a very similar concept year on year. The RB20, the RB21, there's not a lot of difference between them because they haven't gone wild with a completely different car concept, and particularly around this area of the car. So what's going on at Red Bull? What have they changed to their braking setup that means that they have to run a much larger duct this year than they did last year? You do have that separate cooling duct down here. Now it could be just general improvement of design, general time in the wind tunnel, general time on CFD, finding a slightly better, more efficient way of doing it. But I don't remember Red Bull having cooling problems on their brake system last year. And so going from that version to the version they have on the car this year, look, it's quite a lot different. It's quite different. It's quite a lot bigger than you have here. And there's that little detail at the top I just wanted to draw everybody's attention to, because I think that's really quite a beautiful little, just tiny piece of engineering detail there. And that's what I absolutely love about some of these cars, those tiny engineering details. And when you come down to looking at the Sauber, this is the Sauber's front brake cooling outlet, again, new part. I just love the technical detail on this. You've got this metal 3D printed part here, the silver bit, and then look, it's a twin element outlet. They've clearly sculpted it down the bottom absolutely beautifully, and I absolutely love that sort of engineering detail. It's really just, I mean, you can't talk about the detail of it without the CFD wind tunnel results and stuff like that, exactly how it works, but it's just beautiful to look at, isn't it? It's real artistry. What you can talk about though is the fact that to get around a corner at this circuit, you have to turn that wheel, and the teams have to modify some of the suspension components just to allow there to be enough clearance to get around one of the toughest corners on this circuit. This one, the hairpin at Monaco. It changes its name occasionally, but sometimes drivers do have problems getting around it. Right, that is not how I meant to do that, but exactly what we're talking about. Drivers do struggle with that corner. In fact, looking at the changes you have to make to that front suspension is something Lawrence Barretto was exploring with the Williams team once more.
There's obviously some specifics about this track that the car needs to deal with around the steering geometry, which with this track and specifically the hairpin, it makes it quite tricky and very different from other circuits in that respect. So we make some modifications mechanically, which increase the ratio of the steering, so how much you have to turn the hand wheel to the road wheel, and it's about 25%. And then because of that, there's some other updates that you make around the suspension geometry, so the boots and the carbon panels that support that to allow that extra steering to get around the hairpin.
Well, it's not just the front suspension that has to be very Monaco specific. all of the drivers and all of the teams have to really struggle to get the right packages on their car for this weekend. Not those ones. And to take a look at how you get a car properly set up for Monaco and be right on the cutting edge, let's hear from some of the experts in the pit lane.
There's a couple of things that you need to do, not only to win the race, but just you need to do to go around in Monaco, and one of that is some modifications on the front suspension. Actually, perhaps you can see from here, there's one of the arm that has a little indentation, and this indentation is to allow enough of a steer angle, which is what you need to go around Loews. Like, this is traditional. This has always happened pretty much in Formula One history. Like, this Loews is a one-off corner in terms of the required steer angle to go around that corner. So you have to make some modification to the front suspension.
The first thing here that is massive is driver confidence. So you need a stable platform and one that they're happy to push the car. So that's really the basis. Also, to cope with the curbs, we run the car quite soft, which allows it to be more compliant over the curbs and helps to build that confidence rather than being pushed off it. I think generally around Monaco you tend to struggle with understeer, which counters my first point that it's probably easier to drive a car with understeer than oversteer, but that makes a slow car around here, so we'll start to move into that, and that's really where the lap time comes as we progress through the sessions and the drivers build a bit more confidence.
In terms of instead making modifications to win, you need to find a good compromise, especially with this generation of cars, to run as low as possible, as close as possible to the ground, because these floors, the closer they are to the ground, the more downforce they generate. These cars are the most ground effect cars that we have ever had in Formula One, in the history of Formula One. But here in Monaco, it's difficult to go so close to the ground because you need to run very stiff. And if you run stiff, then when you run a curb, like in the second, here actually, in the second chicane of the swimming pool, then the car will be rigid on the curbs, and then you lose performance because it's too rigid. Or when you brake into corner 3, the casino corner, the car lifts a little bit, so you want the wheels to follow the road, and if the car is too stiff, you don't follow enough the road. So it's the typical compromise between generating aerodynamic grip by running low and stiff, but having some good mechanical grip with good ride.
So to get the correct setup at Monaco then is no easy challenge. So to answer the question we started with in the title of this video, how do you win the Monaco Grand Prix? Well, you drive fast, you don't hit the walls, you get the right aerodynamic package and the right setup. Sounds easy to say, it's certainly not easy to do, because get even the slightest thing wrong with the shape of your car and you will be nowhere on the streets of Monte Carlo.